Welcome to Differential Equations, Chapter 2, Section 2. In this section, we will be learning about separable equations. So we solved some separable equations in Chapter 1, Section 2. And these were mostly of the form dy dx is equal to ay minus b. Both a and b are constants. The way we're going to prove that these equations are separable or by getting it in this form. So we have function m that has both x and y, and then we add n, another function x and y, times dy dx, and this must equal 0. So we're going to be solving these types of equations today. The first example we have is dy dx is equal to x squared over 1 minus y squared. So we can multiply this over to the left. That will get us 1 minus y squared. That quantity times dy dx is equal to x squared. We can subtract the x squared over, and we'd have negative x squared plus 1 minus y squared times dy dx, which is equal to 0. So we can say this function is actually m, and then this function is actually n. And the goal is we want to have m is just x, and n is just y. The reason why we want this is so we can actually separate the y with dy and the x with dx through multiplying each factor by x. So we multiply x over, we'd have dx, and we'd have 0 times dx, which would still be 0. So we can separate this out. So we'll multiply everything by dx. So we have negative x squared dx plus 1 minus y squared dy is equal to 0. So now we can integrate both of these, because we have with respect to x, x, with respect to y, y. This is going to go to negative 1/3 x cubed, and then we're going to be adding 1 just goes to y minus 1/3 y cubed plus c. We can just put the plus c on this one. We don't have to include it because there's two constants. We can just combine them together, and this is going to be equal to 0. What we'll do is we'll actually multiply everything by 3 just to simplify it. So we'd have negative x cubed plus 3y minus y cubed, and we'll subtract the c over, but we always keep the c positive, and we'll just have it plus c, because it's, once again, it's any constant, can be positive or negative. And we can say this is our solution. We could solve for y, but it's easiest to leave it in this form to find your constant of integration. The next problem that we have is going to be dy dx, which is equal to 3x squared plus 4x plus 2. And this is all over 2 times y minus 1. So once again, we want to find it in m of x plus n of y times y prime, or dy dx, which is equal to 0. So once again, we'll multiply this entire denominator over. So we'll have 2y minus 1 times dy dx, which is equal to 3x squared plus 4x plus 2. We can subtract this entire polynomial over, which means we will have a negative 3x squared minus 4x minus 2. We'll put this in parentheses just to make the m more noticeable. And then we have plus 2y minus 2, just simplifying that, times dy dx, which equals 0. So this function m, it only has x's in it, so we're good on that part. This function n has only y's in it, so we're good on that part. So we'll multiply every single factor by x, which will give us this. We have 3x squared minus 4x minus 2 dx plus 2y minus 2 dy, which is equal to 0. Next, we can integrate both sides, or both factors, and this will actually go to negative x cubed. That will go to negative 2x squared minus 2x. And then we're adding y squared minus 2y, which is equal to 0. And we have to add the constant, forgot about it, so we'll have plus c on this side, but we'll actually take it out and we'll just make this equal to c. And we can say this is our solution. Once again, don't worry about simplifying it into just y, because it's easiest to find the constant when you have it in this form. You're not dealing with any fractions or any square roots or anything like that. I believe there's one more problem. Yep, so we have one more, and it's going to be dy dx, which is equal to y cosine x over 1 plus 2y. So this will actually go to 1 plus 2y times dy dx, which is equal to y cosine x. We can actually divide both sides by y, which will actually give us this. 1 plus 2y over y times dy dx is equal to cosine x. And then we'll move the cosine over, which gives us negative cosine x, and we'll multiply by dx, because this right side is going to be 0, just skipping a couple steps. And then we're going to have plus, and we'll simplify this, 1 over y times dy dx plus 2 dy dx. But then we also multiplied the dx over, so we'll take the dx's out. And it is equal to 0. So once again, we can integrate both of these, actually all three of them, and this will give us the integral of negative cosine is going to be sine, negative sine of x plus c. Integral of 1 over y is going to be ln of y, absolute values. And then the integral of 2 dy is going to be 2y, which is equal to 0. And we'll simplify this just a little more. We'll have ln y plus 2y minus sine x is equal to c. And we can say that is our solution.